Perfect. All right, first of all, actually, I want to take a quick little poll here. Who's actually familiar and has heard of Dgraph before? Is it going to be new to everybody? Good. That's what I was hoping to hear, actually. So let me share my screen here and we'll get started. So we will do Microsoft PowerPoint. Yes, I'm still using PowerPoint. Let me know if you can see that there. All good, Bill? Hopefully you can see, or someone can give me a thumbs up. Awesome. All right, so today we are going to go over from zero to GraphQL the Dgraph way. And it's going to be a little different probably than what you're used to. Because normally we build things from scratch, or maybe we use a platform coupled with something else. I'm going to show you what basically a backend platform looks like that supports GraphQL. Head to the next slide. So on today's agenda, what we're going to do, if I can move this Zoom stuff up to the top, there we go. Today's agenda, well, first we're going to talk about graph databases. Then I'm going to look at GraphQL plus a graph database, then do a Dgraph overview, and then we'll do a demo. And Daniel, my colleague, is with me as well. That's going to show you some stuff that just prior to this, I saw him do, and I was like, man, you totally got to come and show them this. So
yeah, it should be fun.
Well, yeah, it's gonna be awesome. So let's head to the next slide here. So first of all, I am by no means a graph database expert, so I'm going to give you a very brief overview of what it is. So what is a graph database? At the root of it, it is a NoSQL database, but it's a little different than what we're used to maybe with a document-based one like Mongo. So what we use in a graph database is nodes and edges, and those store the data. Then the nodes store object data, and the edges can store relationship data. Now that allows for, compared to if you think about when we start to combine relationships in Mongo, it's a lot of a manual process. We have to know a lot about the database schema in order to put those relationships together. With the graph database, we can actually use the edges to support that. So we can do a lot of these really complex relationships that we can't necessarily do in a NoSQL database, like a document-based one, or in SQL. We can store many different relationships between these nodes. The cool part about it is that it actually eliminates the need for SQL-style joins. So many of you are probably familiar with these really large joins in your SQL queries when you have a lot of data that you're trying to bring together. You don't actually do any joins in a graph database, so you don't need to worry about that. What I like best about this, and I discovered Dgraph actually on my own before I worked for the company, and the reason why we use it is because we had a lot of simple data. And then as I got introduced to the company, I realized, wow, we can support simple data, or we can support extremely complex data as well. And we have some quite large customers that are using our platform to do, big knowledge graph stuff, or things that you would normally see done in something like a big data platform like Hadoop. We're able to do within this solution that can support small and really big use cases. What I did put in the corner here is this little diagram. So, you might have a user, a tweet, and a hashtag, and those would be objects. And then on the edges, you could actually have relationships that connect those. So, a user authored a tweet and it was tagged with a hashtag, and you can actually traverse this graph and pull out a lot of good insights and also query the data more easily. If you want to know more about it, we've got lots of stuff on our site, and there's lots of online resources too. So a couple of reasons why you would want to use a graph database. And truly, honestly, I can't really see a scenario where you wouldn't want to use it, but there's a few places where it really shines. And that is in performance. So it's extremely fast, and the response times are really consistent. So even as queries become more complex, we still find that unlike SQL, or SQL, obviously as queries become more complex, the response times tend to go up. You don't really find that with a graph database because of the way that the data is structured. You have flexibility, so you can easily add or manipulate the schema in the database without breaking the data, which is kind of a hallmark of even a document-based NoSQL instance. And simplicity. So if you actually look at, we do have a couple examples of it, and I'd have to look them up, but we do have examples of where here's this gigantic SQL query, and here's the equivalent with that data in a graph database. So what it does is it allows you to write queries more easily, and it's a major reduction in lines of code / script. You end up with a one single line in a query might be this massive equivalent of a SQL statement. Graph database use cases. So they truly are multi-purpose database because it balances this nice, this flexibility that we see with a document-based NoSQL database, but it also gives us that relational portion of SQL databases that you might be missing somewhere else. So commonly used for, you could use it for fraud detection, recommendation engines, data consolidation, unification, knowledge graphs, or my favorite, just plain old application data storage and for just a regular backend. Now we all know what GraphQL is, so I'm not going to go over that. Let's look at what a GraphQL plus a graph database, kind of those benefits there. So when we think about how GraphQL is structured, it actually lends itself really, really well to how a graph database structures data. So the nice part is about when we look at a platform like Dgraph, which has a GraphQL layer in it, as well as a graph database, and I'll show you what that kind of schematic looks like after. But the two are so closely related that in Dgraph, we can actually create a GraphQL schema, probably the same ones that you're creating when you're, when you're using Node or whatever platform you're using or whatever framework you're using. You can take that, drop it in to the graph database as a schema for it, and it will automatically generate the database schema, plus it'll generate a GraphQL API. So a single schema, because GraphQL lends itself so well to the format of a graph database, we can use that to do both sides of the backend equation. Now for the Dgraph approach. So as I kind of alluded to, Dgraph allows you to do all of this stuff kind of in one platform. So when we think about it, it's a graph database with a GraphQL API built in. And I yesterday was kind of thinking like, how could I describe it? And it's what it really is it's a backend in a box. We're able to just, pop in the schema, and our whole entire backend can exist off a single GraphQL schema. So you could also refer to it as a GraphQL / backend platform because your entire backend is in one place. But what you need to do is you'll have to generate or define a GraphQL schema, maybe one that already exists, and you can be operational in minutes. And I'm going to show you that probably it's going to take us about 10 seconds to create a backend, which is quite cool. So the goal of this was to make GraphQL and graph databases easier to use. I know many people on the call probably have never used a graph database before. I had never used a graph database prior to my little project with Dgraph as the backend. So it really does add simplicity to that. And as I mentioned earlier, being able to accommodate simple and complex data and use cases is great. So if you use Dgraph for maybe your project that you're doing at home, you could also translate that and use it in enterprise as well. And there's going to be no difference in the database or the platform itself. It can support both use cases. Dgraph benefits to developers. So all database schema, all database schemas have API definition are controlled. So the schema for the database and the API definition are all controlled through a single schema. So you don't need to create, if we think about how we would normally do with SQL, we'd have our SQL schema that we would create, deploy that, then we'd have our GraphQL schema, create that, and then we'd have to create our resolvers to make sure that we can map this data in. We might have microservices that we're calling to all of this very, very complex GraphQL setup. We don't really need to do that with Dgraph. Ultra fast performance, even at scale. So Daniel's actually going to show a query run against that he's going to run against, I think, 21 million different data points. And it's going to return in, very, very few milliseconds, these very complex queries. I like the fact that Dgraph also allows me to really easily integrate with a preferred IDP. So for the project that I was working on before I worked for Dgraph, we decided to go with Auth0, and we were able to plug in Auth0 in a matter of minutes and have the schema pretty locked down. Minimal maintenance and support. So obviously having everything in one place means that normally when we create new GraphQL services, and Robert, this probably plays into sometimes why we can't adopt GraphQL in larger instances, because it's not just about building it, it's actually about supporting it. And if you have a support team that is supporting GraphQL services that's external to the original development team, there's obviously a learning curve there for them to be able to support that. And that's sometimes also a concern of adopters. We have decreased backend code. So what I'm going to show you is basically you can generate this whole entire backend with 0 lines of code. It's not a code generator. We don't generate code. We don't do any of that. We actually have an engine built in that runs both the Graph database and the GraphQL API. As you can imagine, this means you have a really simplified architecture. So now you might just have your mobile app, your web app, and then you have Dgraph. You don't have, this complex architecture in the background. You can boil that into a single component. This might be reminiscent of, if anyone here has worked in PHP, where you have direct database calls coming through the front end code. It's not like that. It's definitely a different approach than that. So I did think that at first. I'm like, oh, we're gonna go back to a 2-tier architecture, because that's obviously circa mid 2000s 2-tier architectures, and then moved into a 3-tier, which is more common with our front end API and then our database. But it's not quite like that. The learning curve for GraphQL and building services obviously is pretty steep if you've never used them before. This type of solution allows you to do it pretty quickly. So you only really have to have knowledge on how to build a GraphQL schema. And after that, you deploy and don't need to worry about learning how to use Apollo Server or anything like that and building things out, or learning any type of GraphQL framework. And lastly, it can be configured through a UI, which I like better, or if you want to do automation, you could also do it through API calls to set it up. Deployment options. Oh, sweet. I got left some lorem ipsum in. That's what happens when you do it last minute. We got Dgraph open source, which is our shining star project. We've got over 12,000 GitHub stars on it. So something to check out. And then we also have Dgraph Cloud. We have shared instances and we have dedicated instances as well. Now, we also do have on-prem stuff. If you absolutely had to, we can support that kind of stuff, but we're really trying to get people onto cloud because we really think that it makes things super, super easy. And I'm going to show you in a matter of seconds here how easy it is to set up a backend on Dgraph. So let me come back. Let me exit out of this here. And I'm going to go back to that slide that I was just on, and I'm going to grab that schema, and I'm going to share my screen with you in a second. I'm going to grab this schema. Where are we here? And come back to Zoom, share screen, and we'll do desktop. There we go. Google Chrome. Let me know when you can see my browser. You're able to see it?
Yep.
Cool. All right. So if you're in Dgraph Cloud, basically you create an account and you can log in. I did this just moments ago. I used Google to sign in. So here I am. And I'm already at the sign up screen. I come over to free. I'm going to select my region, which is already pre-populated, and I'm going to launch my backend. And you would go through the same steps. If you were to sign up right now, you would come to that exact same screen. And now this is the UI. So I'm going to come over to schema. Now we do have a language called DQL, which is Dgraph Query Language, which is a little more, it's an extension of GraphQL. It allows you to do a little more stuff. Daniel's going to show how that looks, but I'm going to show you that if I plug in a GraphQL schema here, plug that in. So we've got, we have a customer, they have a username, they have reviews, reviews type, ID, about, buy, comment, rating. And then you'll also see that we have product. And then you'll also see that we have a couple of these annotations here, okay? So we have has inverse, and that's going to allow us to actually establish relationships between this data. When it stores in the database, it's going to store with that relationship, and we'll be able to retrieve it with those relationships in mind. A little different than what you would normally see necessarily from a NoSQL document-based database or from a regular GraphQL schema per se. So I'm going to click deploy. And just like that, I actually have a GraphQL service, and I also have a backend set up ready to go. Now I'm going to go to API Explorer, and you'll see that I'm going to exit out of history. You'll see that, everyone's pretty familiar probably with this graphical interface at this point, but I can do stuff like, get product, query customer through queries, and I can also do mutations. So if I wanted to, add a product, I might add a product name and call it test product. And I think that's all I would need to do. So I can add that there. And I won't go into too much detail because I want Daniel to be able to show his stuff. But if I go over to Data Studio, you'll actually see that this is my database, the actual data that's in it. And I can see that I have GraphQL types. I have product, which is the one that I just created, which is test product. Now, I haven't played around with this one too much, but let's just do another mutation. And I'm going to do a click plus. Yes, there you go. And then I will do add a review, and I can do product ID. And I think I just need to do product ID. Username, I don't have any users right now, so we won't do that. But I can do comment. I don't know if this will work, Daniel, but it might. I didn't have any of these queries typed out ahead of time. So product ID, I'm going to actually open up my Data Studio in a separate tab. Oh, darn, this is in my way. There we go. And then if I can hide this, hide video panel. That's what I wanted to do. And then hide name annotators, and then hide floating meeting controls. There we go. So if I go to my Explorer here, this actually has an ID, which is at the top here, if I'm correct. We've had some changes in the UI lately. So this is my product ID. I think that should work, right, Daniel? I think so. Sorry, folks, I literally put this together because Bill, I got a hold of Bill last night and asked if I could, take over the slot. So bear with me. Daniel's got some cooler stuff to show. I just wanted to show you how easy it is to do this. I guess the point is, let me see if it'll work. Couldn't write me to username cannot be empty. Oh, okay, so I won't be able to do it because I need to add a username. Regardless, I don't want to spend too much time on it because I want to really hammer home the details that what we've done here is we've taken a schema, it's generated a GraphQL service and an API, and a backend all in one box. I mean, think about how quickly I created that. Any of those concerns about GraphQL taking too long to implement or being too complex to support, you can see that we're powering this whole entire thing via a single schema. So let me just grab, if I go like this, there we go. I'll do stop share. So I wanted to kind of demonstrate how easy it is to take a schema and build that out. Now I want to pass things over to Daniel because he actually can show, whether you're going to show it through DQL or GraphQL, Daniel can actually show the power of how the data really closely relates to the GraphQL query language itself. And Daniel, I'll pass it over to you.
Let me share my screen.
Yep.
You can see the cloud dashboard again for Dgraph Cloud.
Yep.
Perfect.
Yeah,
so this is a backend that has, as Matt said, 21 million movie facts, so 20 million different data points. And if I click around the dashboard, just like Matt did earlier, You see we have a schema. It has things about films and directors and actors and the corresponding characters they acted in and the genres for each movie. I can also click on the UI mode and get this sort of the same interface as well for the schema. And we even have things within the schema itself that automatically index different fields, and we can choose the different like search criteria. So in this case, like you can search for names of the art directors by like regular expressions or by term search or by full text search and so on. And so we can actually write a query here in the API Explorer together. Let's say we find the movies directed by Steven Spielberg, right? So I'll go to query director, I'll add a filter for all the directors that match the name Steven Spielberg. And like also goes over. And then we can get, you know, the name of that director. We can go ahead and get the films for that director. We can grab that name of the film. We can grab the date that the film was released in. We can get the country that the film was produced in. What else can we get? A whole bunch of different fields are here. We can get the corresponding actors and characters for this film. And we can also get, I think we can also get the genres. Why not? The genres up here, the genres for this film. So we can go ahead and we already created this query. I'll name this Spielberg Films. We can run it. And then I can show you the response over here. So again, we run the query. It came back pretty quickly. And we have all these different pieces of information. So we have Steven Spielberg as the director, the corresponding films. In this case, this one's Hook, released in 1991, produced in the US, and has the actor John Michael playing the doctor, and so on and so forth. And a whole bunch of different films here, just in this single query. And again, this entire API was generated from the GraphQL schema. So you set the GraphQL schema, you get the corresponding GraphQL access to all your data. You can mutate it, you can query it, you can do pretty much whatever you want with the data. And it's like in this same structure where you can pretty easily understand the structure of your data and also query it. As Matt said, we can show off DQL as well. So I can go ahead and run a DQL query up here. Brings to this interface where we also get a graph visualization. So I can run sort of the same query we did earlier. And GraphQL and DQL work really well together. So you can like have the same sort of structure between your data. And I can run this query and I get the exact same thing we did before, which is the Steven Spielberg movies. In the middle here, we have Steven Spielberg as this blue dot. And then like all the green dots are, all the green nodes in the graph are movies. And then the tan nodes are like the corresponding actors that had played in the movie. And you can even see some connections visually already. Like this one is Indiana Jones. And there's a genre node for adventure film. And so Hook and Indiana Jones like share the same genre over here in the connections. And like you already get a lot out of the box from GraphQL, and DQL brings more to the table in terms of more advanced functionality. So say we wanted to run a query like not just getting the films from Steven Spielberg, but understanding like, hey, Steven Spielberg likes to do cameos in his own movies. So how can we find which movies those are? So I can like show that query to you here. And what are we doing here? That sort of looks structurally similar to the previous query, but we're doing some special things in DQL, like using variable assignment. So we can store results of a query in a variable. And then we can then reference that in other parts of the query and even, you know, reference those same nodes within the same structure. So in this case, we're finding Steven Spielberg. We're gonna, you know, just like before, get the name for this node and all the films. But for the structure where we find who acted in the film, we're only going to find the ones where Steven Spielberg is the actor. So I can run this query. I get 3 nodes here. I can go to the JSON response. We'll see that, you know, Steven Spielberg directed Indiana Jones, played tourist at airport number 2. He directed Jaws, played the Amity Point life station worker, and also, you know, directed Jurassic Park and played the popcorn eating man. So you can start to get a lot of insights really quickly in your data in GraphQL and GQL.
Yeah, and that's kind of the power of the graph database in the background. And the graph visualization also helps you, like, of course, it's just a visual, but it's nice to be able to see, because when we query something like SQL, we get all these tables back. We can see all this stuff kind of laid out. It's very tough to think about how data is laid out when it's more abstract. And that graph, that the rattle look, it allows us to be able to easily see exactly how that data is related. So yeah, I think that's it for us, Bill. If we can take questions now, if anybody has any. There's probably a lot to take in. It's a little bit of a different way of doing things, for sure. But yeah, if you have any questions at all, I'd be happy to answer them for you.
Hey, so I don't have a question, but this looks really awesome. The visualization you mentioned, it reminds me of back in the day, I used Neo4j, and they had another graph database, and they had similar visualizations. And I remember really enjoying the user experience or developer experience with that. So that's kind of cool. And then some of the other tools that I've used in the past are like OrangoDB and Prisma. And it seems like the things that I like about those tools are kind of all combined in one into this one. So this is pretty awesome.
Awesome, thanks. Yeah, no, we appreciate that. We do. I see Mitch has joined. Did you catch? Were you able to catch some of that?
Yeah, I came in like 10 minutes ago.
Okay.
But
okay.
really neat. I haven't seen Dgraph before, or I've seen it, I just haven't used it.
Yeah.
Maybe I missed this, but how do you guys tackle like authorization?
Daniel, do you want to tackle that?
Yeah, I think so. Authorization, you can do it at the schema level. So we just accept JWT tokens. And so whether you're using Auth0 or any other provider, you can hook those in and then apply custom auth rules. So you plug in your own authentication, and then Dgraph, in Dgraph, you can, define your own authorization rules. You can say, hey, only if you're writing a CMS or a blog, you can say the author is the only one who can edit it, but everyone can read this blog, can read it, but only the author can edit it or delete it or things like that. You can apply these auth rules at the schema level for all your GraphQL types.
Are those done via like directives, or is it something else?
Yeah, we have a custom auth directive in the schema. So you define those per type, and then you can do things like set the CRUD rules, the create, read, update, delete rules, depending on whatever structure you have. You pass in your JWT, which has a certain set of claims, and you can use those claims in your schema and your query processing.
Are they like preset claims that have to follow a certain pattern?
You can customize it.
Yeah.
Yeah.
Cool.
Yeah, we support JWTs. We also support JWK URLs. So for example, if you're using Firebase authentication, you can plug that in to Dgraph as well.
Nice. Yeah, that's something I've never fully understood with like a lot of the hosted solutions, but I'd be really curious to see that.
Cool.
I think just one more thing to add there is that there's like 3 levels of sort of auth in Dgraph. The first one is at the cloud level itself. So you can define what you want to expose to the world to begin with. So that phase, some people had concerns about, hey, it's like my data platform. Can I expose that directly to my client? And so typically they would put a layer above the platform itself. And so we did that by having an auth inside Dgraph Cloud. And then we have the JOT, as Daniel mentioned, which is RBAC access control. And then finally, we even have a relationship level, predicate level access control. So we have 3 different levels to choose from. And maybe like the simplest thing to do would be for people to just use the cloud auth and not have to worry about anything deeper than that.
Mm-hmm.
And maybe they want to use a mix of cloud auth and RBAC or predicate level auth.
Cool. Thank you.
Thanks, Manish. Manish actually wrote Dgraph. So I know he joined a little late. Manish actually wrote Dgraph. He is the founder and CEO. So I asked him to join just in case something came up quite like that.
Nice.
Awesome. Well, if there's no other questions, Bill, we'll let you carry on and Robert can take over.
Nice. Thank you. Great
Awesome. Thanks, everybody.
Virtual clap, virtual clap. All right.